Hello dear friends, welcome back to online video sessions of Advanced Internal Combustion Engine. In this video session, we are going to continue with the combustion. So basically, like in previous video session, we have understood, we have gone through the combustion in SI engine, and especially for this video session, we are going to study or we are going to go through the combustion in CI engine. Now, the combustion in CI engine is a lot more complicated as compared to the SI engine, because in SI engine we provide the spark to the mixture of air and fuels, and that would initiate the combustion. But in CI engine, the combustion began spontaneously without any need or necessity of the external device. So basically, in suction stroke only air is taken from the atmospheres. In compression stroke the air is compressed, and at the end of compression stroke the fuel is injected with the help of fuel injector in compressed air, and all the mixing, atomizing and the vaporizations of the diesel takes place in a shorter period of time. And since the both pressure and temperature is high in combustion chamber, it would begin the combustion process in CI engine. So in short, within the shorter period of time, let's just in a few microsecond, or the mixing, atomizing and vaporizations of the diesel takes place in heated air, and that would initiate the combustion in CI engine. So as I said, that it is a lot more complicated as compared to the SI engines. Now here we are going to see what are the different stages of combustion in CI engine. So you will see the diagram here that describe the pressure and the crank angle on x-axis and pressure on the y-axis. So basically these are the four different stages of combustion in CI engine, right? That can be divided in four different stages. The first one is pre-flame combustion, second one is uncontrolled combustions, third one is controlled combustion, and the fourth one is after burning. So we are going to see each of them one by one through these graphs. So you will see that at the end of compression stroke, when piston is about to reach to the TDC, right, before it reach to the TDC, the injections of the fuel takes place into the combustion chamber. So that is few degree before it reach to the TDC. So you will see the point A where the injections of the fuel takes place, right. Now since the injections of the fuel takes place initially, the amount of release of heat is less as compared to the given by these fuels, and therefore the pressure drop takes place, that can be shown by the curve here A to B, right. So pressure would drop, and that is drop because the fuel is injected. So basically what happened when fuel is injected, it atomized first and then vaporize in heated air, and to vaporize the fuel it required the air from the surrounding heated air. So therefore the slight reductions in the pressure takes place, that is shown by the A to B. So A to B is known as the pre-flame combustion. Basically in that stage the flame does not appear, right. Flame does not appear at this time, right, and overall energy release rate is less as compared to it is been absorbed by the fuel for the vaporization purpose, and that's why the pressure drop takes place. That from point B to C, you can see the point B to C, the combustion would begin, and when it reached to the point C, almost all the pressure losses that been takes place can be recovered. So the dotted line represent that the pressure of the non-firing cycles, and you can see the C is almost on the path of the dotted line. So all the pressure loss that is being takes place in between the pre-flame combustions can be recovered at point C. Now point C to D is known as the uncontrolled combustion. is known as the uncontrolled combustions. I'll tell you why. Because like at initial conditions, all the fuel which is been injected into the combustion chamber, right, they would start to accumulate inside the combustion chamber. Since the flame does not appear here, since the actual combustion does not start here, so all the fuels that is being collected into the combustion chamber, they would start igniting together, and therefore at the initial stage the combustion takes place in uncontrolled manner, right, because all the previous fuel that is been collected into the combustion chamber, they get accumulated and they all start igniting together. So therefore at initial stage the uncontrolled combustion takes place. Then after, from point D to E, all the combustions that is been takes place is known as the controlled combustions, because since all the accumulated fuel is get burnt, and now the combustion takes place only the amount of fuel which is been continued to injecting into the combustion chamber. So after that the curve would be smooth, and the overall combustions that is been taking place inside the combustion chamber is known as the controlled combustion chamber. And the last one is the afterburning. Now after the point E, right, basically this does not contribute much to the overall power gain into the combustion chamber, but all the carbons and hydrocarbons that is left behind into the combustion chamber, they continue to burn into the combustion chambers, and that combustion is known as the afterburning. So basically afterburning has nothing to do with the overall power gain into the combustion chamber. So these are the four different stages of combustion in CI engine: pre-flame combustions, then controlled combustions, then uncontrolled combustions, then controlled combustions, and the afterburning. So these are the different stages. Now next things that would come in our topic, which is very important, and that is known as the ignition delay. Which one do you call the ignition delay, and why does it happen in CI engine? So basically, like we have understood that at initially all the fuels that is been injected here, they would not start instantly, start burning instantly. That ignition does not start burning instantly. Initially it gets the atomize, then vaporize, and then after it start burning. So there are a few for the few microsecond that is been represented by the alpha here, right, that is known as the ignition delay. After that it start the burning. So the delay period is the time between the start of injections and the start of ignitions, that is in between A to C, right. So there is a small delay period, and that is known as the ignition delay, right. Now why this ignition delay takes place, and what are the factors, right? How would you divide the ignition delay in two different categories? So basically ignition delay occurs because the ignition does not start instantaneously, and it is been divided in two different categories: physical delay and chemical delay. Physical delay is because of the like atomizations and vaporizations of the fuels. So it required a few seconds to atomize into the small droplets and to vaporize along with the or in the heated air. So that is because of the physical delay, and chemical delays depend on the chemical nature of the fuel. So basically ignition delay is divided in two different categories: physical delay and the chemical delay, right. Now what are the factors that affect the delay period, right? The first one is the types of fuels, right. What are the types of fuels are you using is very important, because like there are a few things like chemical characteristics of the fuels that is play an important role for the delay period, right, such as the velocity, viscosity of the fuels, then the self ignition temperature of the fuels. If we have the low self ignition temperature fuels, then delay period would be smaller. Then C10 number is also play an important role. If C10 number is high, then delay period would be lower as well. So the first and very important factor which affect the delay period is a type of fuels that is being used into the IC engine. Then second one is temperature and pressure of intake air. Like if both temperature and pressure of intake air is higher, then the delay period would be lower, because if the temperature and pressure is high, then the fuel gets start burning quickly as compared to the other conditions, and therefore both temperature and pressure play an also important roles. Then the compression ratio, if the compression ratio is high, then the delay period would be lower as well. Then next one is the injection pressure and injecting timing, right? If the injection pressure is higher, right? If there is an advance in injections of the fuels, then in that case the delay period would be lower as well. And the last one is engine load and engine speed. They play also important roles. Like in both cases, if the engine load is high, if the engine speed is high, then in that cases the delay period would be lower as well, right? So these are the factors which play a very important role for the delay period. Then after, knocking and detonation in CI engines. Now knocking and detonations is the major problem in CI engine. You can see two different curves here, right? One represent the normal combustions, another one is represent the abnormal combustion or knocking. So you can see in the normal combustions, the all the combustion curve is very smooth, right? Whatever the four different phases of the combustion is, that is being takes place in the smooth manner, right? Such as pre-flame combustion, uncontrolled combustion, then controlled combustion, then the afterburning. These all occurs in a smooth curves. But in abnormal conditions, because of the delay period, the large amount of fuel get accumulated, and as the quantity of these fuels is higher, the uncontrolled combustions takes place. As you can see, after pre-flame combustions, that would be release a lot of amount of pressure, and because of that the knocking occurs, the stinking noise into the IC engine occurs, and that can be represented by the curves here for the abnormal combustions. So basically, at initial conditions, when the lot of amount of fuels that is been accumulated into the engine, and they would create the abnormal conditions, and that is known as the detonation or knocking in CI engines. Detonation and knocking release the larger amount of power, and there is a possibility of damaging of the engine component as well, such as the inlet valve, exhaust valve, or the piston head as well. Now we have seen the knocking in SI engine as well and in CI engine as well, but they both have a difference. You can see the difference by looking at this curve. Like the diagram A represent the knocking in SI engine, while diagram B represent the knocking in CI engine. So basically in SI engine, the knocking takes place at the end of combustion stroke, at the end of combustion process, while in CI engine knocking start at the early stage of the combustion process, right? In CI engine, whatever the amount of fuel that is remain sorry, in SI engine, whatever the amount of fuel that is remain unburned would start automatically igniting, and that would before the flame wave reach to that portions, and they would start igniting by itself, and that is called the knocking. While in CI engine, all the fuels which is accumulated because of the delay period, and they would start igniting in uncontrolled manners, and that is known as the knocking in CI engine. So basically you will see the difference of knocking in both SI and CI engine. Now, what are the factor which affect the knocking, in especially in CI engine? So basically, we'll go one by one. The first one is a fuel, right? If we have the good C10 number of the fuels, we can reduce the knocking. Then intake air, right? Intake air temperature, intake air pressures. If we both have higher, then the tendency of getting knocking is lower as well. Intake pressure, if the pressure is high, then tendency to get knocking lower as well. Load, if the load is high, then the knocking would be lower as well. Then injection pressure and compression ratio, if they both would be high, then in that case the chances of getting knockies into the CI engine would be lower. Then after, how would you control the detonations? What are the different ways which can be used to control the detonations? And the first one is using better fuels. If you use the fuels which has the high CTAT number, then there is definitely chances to reduce the delay period, and if the delay period is reduces, then there is a less chances of accumulations of the fuel in the initial stage of the combustion in CI engine. And if the quantity of the fuel would be accumulated into the engine, accumulated into the combustion chamber is lower, then there is a less chances of the uncontrolled combustions or the detonations. So if we use the better fuels, there is a less chances of the detonations. You can also use the anti-knock additives into the fuel as well, which is reduce the chances of knocking and detonations. Then controlling the rate of fuel supply. Now we have understood that the detonation occurs because of the accumulations of the fuels, and that is due to the delay period. But if we control the rate of fuel supply, then there is a less chances of the accumulations of the fuel in combustion chamber. And if less amount of fuel is accumulated, then we can reduce the chances of detonations. So if we control the rate of fuel supply, we can probably adopt the such type of the fuel injection system, in which the lesser amount of the fuel is injected at the initial stages, and as soon as the combustion start beginning, we can like inject the remaining amount of the air into the combustion chamber. So this could be the way to control the detonation as well. And the last one is knock reducing fuel injector. Like we use the fuel injector to inject the fuel. So if we have the such kind of the injector which has an ability to reduce the knocking, right, we use this such kind of the injector that can like atomize fuels at rapid manner as compared to the older one, and that would vaporize the fuel quickly as well. So overall delay period would be reduced, and due to that the accumulations of the fuel would be also reduced, and that reduce the chances of knocking as well. So these are the few ways where we can reduce the chances of detonation in CING, right? So this is all at the moment. If you have any doubt, you can write down in the comment box. Thank you very much.